My name is Burek, and this is Steve Boisvert, and we're from a company called Auros Systems. And we have a knowledge-based system software application database that grew out of the automotive industry. And the whole focus of it is to allow a company to capture its knowledge being technical, rules, lessons learned, best practices, put it into a single location that is then distributed to the engineers as they need it, when they need it, in a way that it becomes very active. So rather than searching, information is delivered to them. And this is how I do it. Okay, good. So for the project that we're going to talk about, Pat mentioned, this is again the NSRP. This was a stated objective to automate the provisioning of information at each step of the ship design process as the engineer progresses through the flow of work. So I'll get a little bit more into that, but just to introduce the members of the team. So we have 4 participating shipyards. We have Conrad, who's in prime. We have NASCO, who have just recently joined us. We have another shipyard that, due to resource constraints, had decided to drop out of the project. So NASCO stepped in. We have Marinette Marine and Bath Iron Works. Each of those 4 shipyards, we're working with them to define the knowledge sources that they want to unitize and deliver. And they're also defining individual workflows that they're interested in. And that's what we're focusing on. On the technology side, we've got Auros ourselves. ShipConstructor, we're working with ShipConstructor. You'll see a little bit of that. Steve's going to be demonstrating that or showing you that. Then we have American Bureau of Shipbuilding. They're providing the rules that we are digitizing and delivering to the shipyards. And then we have 2 consultants, Lisa Ellis from Heppenstall Consulting and Vicki Blugo-Kecki. I'm getting better at saying her last name. I had to introduce her at the conference. So as 2 guys coming from the automotive industry, she has been invaluable in explaining to us just what the heck shipbuilding is. So it's been fantastic from that standpoint. So why are we doing this? So the challenges that many industries face, as well as yourselves, are cost pressures. And those cost pressures, a lot of them can be reduced or minimized if you're doing the design properly. So it's important that the engineers are aware of everything they need to know at the upfront design, so they don't have to do it, you don't have a problem with manufacturing, and you're meeting your obligations or requirements. Complexity, shipbuilding, just like every other industry, is going to be extremely complex in terms of not only production environment for a particular product, but 20, 30 years ago, valve was a mechanical device. Now it is an electronic device that's connected to all sorts of systems across the ship. So the engineer needs to understand those connections and be able to consider that as he or she's going through the design. Regulations and requirements just continue to build up more, to get refined, to get new ones all the time. Workforce attribution or attrition. You've got many individuals, engineers that are reaching retirement age or leaving. As they walk out that door, they're taking 20, 30, 40 years of experience and knowledge that has not totally been translated or transferred into the company. And then finally, balancing disciplines. We've got things like design for manufacturing, design for production, all put together to help reduce the cost pressures, but that means the engineer needs to understand and know about all those disciplines as they're making decisions. This may look familiar to you, but this is typically, I know how the automotive industry has operated for years. There are requirements, there are standards, there are lessons learned, they're captured in documents, they're put into a library model. We came from Ford. At Ford, we were fantastic at putting together and collecting all sorts of information from best practices, lessons learned, things gone wrong, things gone right. They got documented, they got put on the shelf, and that's the last time anybody ever saw it. It was never any real thought about how to deliver to the individual. We consider this to be passive, very passive model. That means it sits there and you have to take the initiative to go and take advantage of what the nuggets of knowledge are. So the problem as we see it is that technical knowledge today is scattered throughout the organization, and engineers have to search for it. And it exists in Excel spreadsheets. It exists, check sheets. Just think of all the check sheets that exist in a shipyard right now, or any manufacturing organization. They're not connected. The rules change. You've got to somehow get all those Excel spreadsheets up to date again. And again, the engineers have to search for the information that they need. Then after that, even if they get all the information that they need, I mean, sometimes they don't even know what they need, the knowledge that gets applied, they're not sure how it got applied because they're in record. And what did they learn from that? There's really no closed loop from the technical memory as it's applied in the workflow engineering. So the proposed solution that we have is using Auros along with ShipConstructor. We're putting together a system that's integrated into the existing engineering workflow. So knowledge, applying the knowledge is not something that's alongside what they're doing. It's part of the actual workflow. He doesn't have to stop working on the computer and go search out some regulations or requirements or designs. It's delivered to him as he works. And that's what I'm talking about here, delivery versus requiring the engineer to search for that knowledge. Active versus passive, there's two elements to that in my mind. First is active, it's actively being delivered to the engineer. The person that needs the relevant information is getting it, put right in his face, his or her face, to make the right decisions. The second element of that is that that knowledge has been structured to be active. I've got a lot of experience looking at lessons learned and things and projects that were completed and documented for future use. They're PowerPoint presentations, they're 40-page documents, they're humongous PDF files. Whoever wants to apply that knowledge has to go through that and internalize it and figure out how that applies to his context. We need to take that knowledge and make it active and structured so that when somebody sees it, it's unambiguous, you know how to apply it. And then the assessment of use, we want to make sure that when it's used, we have traceability and we know how it was applied and was it in compliance or not. It's impossible to be in compliance with all rules. So let's keep track of the ones that were not in compliance and use that to refine those rules and figure out how we do that. So how do we do that? We go from a library model, take that information out of the books and the PDF files and the PowerPoint slides, and we break them up into unitized bits of knowledge. Very specific, templatized knowledge that looks the same, but it's got required information, it's tagged, and it's unambiguous, and it's active, so it actually says what needs to be done with the job. And those things are what we call knowledge packets. Those knowledge packets are designed so that they are both in textual form, in readable form. They're also in digitized form, so we can deliver them to the engineers through what we call them assessment controls. But an assessment control is really an intelligent spreadsheet. They're all connected, but they're all coming from a single source of knowledge. So if that single source of knowledge changes, any assessment that's connected to it is updated and notified that there's a new version of that tool. It also captures that knowledge in a digitized form that allows it to connect to digital engineering tools, CAD, PLM, CAE, and that's where the magic of this project starts. Steve's going to talk to you about now. Right? Yeah.
Greg took you through kind of the high-level knowledge management. There's a lot of information out there. It needs to be delivered, harvested, and impacted the full work. So I want to talk more about specifics of the actual project that we're doing. So, as Greg mentioned, we have 4 different shipyards. First thing is we're going to talk about shipyards and said, what are your problems? What are your problem areas? Where are you having significant issues So each of them had a little bit different areas that they want to cover. So some of them were talking about, we have a lot of specifications, a lot of regulatory rules, a lot of work instructions that, aren't being reviewed. We need to get those into the workflow. Piping rules, penetration information, we're having trouble with that. So we came up with a plan, and as part of that plan, the first step was to take some of their existing documentation, start converting it into knowledge packets. So our team, along with the shipyard, started to break that information down. Next was we need to start to get that information into their flow of work. So their flow of work is I'm designing, the ship structure. I need to go, search some library or other folder. We need to get that in the tools that they use. So it was only natural that we need to create a connector between our application and ShipConstructor because that's where the work is being done. So we started to develop a connector to ShipConstructor. Once we've done that, we're able to integrate the two systems together and provide a knowledge delivery system. So going down a little bit more of an explanation. So what's a knowledge packet? Well, on this project we have ABS. They have, you guys know, they're gigantic rules. They have PDF files galore. And the way that the shipyards for tunnels they have to deal with them is they go in there, they do Control F, look for what they need to apply. And it wasn't efficient. So as partners on this project, actually ABS already recognized that was a problem. The delivery mechanism of PDFs just isn't going to work in this intelligence revolution that's about to happen, or is happening. So they already started to digitize some of the rules. Well, we said, well, we have a digital solution. We have a digital solution. Let's build a mechanism that we can transfer information. So we built a mechanism where we can take their ABS rules and mass convert them into what we call a knowledge packet. So this knowledge packet is a granular bit of know-how structured for reuse. And I point that out because the main importance here is just one small bit of information. This is that one rule that you need. You don't need the entire book. When you go to apply something, you want that one rule or that one collection of rules relevant to what you're doing. So we break their rule packets down into what we call knowledge packets. And they're structured in a way that they still have that contextual area that people are used to. But we also have little logical models that can execute rules and evaluate themselves. We also have areas on here that we can apply metadata to make them intelligent to know when, where, and who needs this information whenever it's called. So other shipyards said, well, ABS is a problem, but penetrations are also a problem. Well, as part of this project, we're taking past NSRP information, which is in document form, and we're breaking those down into knowledge packets. An example of that is the penetration standards, broken down by the different types of penetrations, by the different types of rules. And we break them down this way. Whenever you're in ShipConstructor and you're doing an uncompensated penetration, we can call Auros and get just the specific rules for that type of compensation. Another area that we're doing is design for production, design for maintenance. Again, they were documents. If they wanted to be applied, they had to go find the document, read through the entire document, and then interpret that information and try to apply it to the project. As a knowledge packet, it'll have some intelligence and be broken down just so the individual bits of information. So knowledge packets, like I said, are those granular bits of know-how. And we want to collect them when we need them. But we also need to know when and how they were applied, right? We want to ensure that that knowledge was used. And the knowledge packet by nature is more of a generic concept that can be applied across many projects. So we needed a way to grab that information when it's needed, bundle it up, and then say, I use these knowledge packets for this particular context. And the way we do that is through a mechanism called an assessment control. So when an application or a user says, I'm doing a penetration for this type of, or I need a penetration for this type of object, we go out and find those knowledge packets, say, all right, I'm working on ship XYZ, and it collects those knowledge packets and puts it into what we call assessment control, where that evaluation or use of that information can be tracked. And so we can store the evaluation, we can store store any of the critical decisions that were made, and then it's a record that we can go back and interrogate later if we need to. So for the project, like I said, we're building a connector between ShipConstructor and Auros. So what does that mean? So now if I have my information in digital form in knowledge packets, and now if I'm that same designer working on a planer group, I can be inside of ShipConstructor and I can call to get information that's in my knowledge repository. So that can even be based on any of the context information that already exists on a part. Maybe it's the stock thickness or the part name or the part type. Once we have a context that we can apply and deliver into our knowledge repository, find those collections of knowledge packets, we can develop an assessment control to store the use of those knowledge packets for that particular part. And then, by the way, we can send that information about that assessment control back into ShipConstructor to be stored. That way, we can track and know that that particular object has been evaluated for criteria we may have needed. So in practice, what really happens, I just want to break it down one more time. You're in ShipConstructor, you're either on a part, maybe you're in the product hierarchy, you're standing on an assembly level. We call the applicable assessment or knowledge packets for whatever operation I'm doing. Once we get those knowledge packets, we convert those into an assessment control specific to that operation or whatever I'm working on, and store that information as part attributes inside of ShipConstructor. So I wasn't going to do this demo live, but I'm glad I didn't because I tried to do it live for Dennis earlier and it didn't go so well with connection issues. So I created a bunch of screenshots to show how this works. So here we have a planer group, we have a part or a series of plates up here. To make this connection happen, we had to build a section inside of AutoCAD to store all of our settings to make the connection to Auros. So the settings module allows us to pick what object types we want to create an assessment on to connect to, which project we're working on, maybe which design phase we're in, kind of some of that metadata that set up the project, which part properties that we want to transfer to collect the right knowledge packets. So once I've done that, once I've set it up using the Auros settings, back in my model, I right-click. In this case, I'm just going to click on a part, or we can go in the part structure and click on an assembly level and whatnot. And when I do that, I'll get a series of right-click commands. And we have Auros tools up here. And what you'll see is there's a series of commands. The first one is open or create an assessment control. So basically what this is going to do is it's going to look at that part and say, do I have an assessment already created for it? If I do, it'll open it. If not, what it will do is it will either collect the relevant context information from the part properties and send that to Auros, or if none have been mapped or exist, it'll open the web interface to an assessment control. And in this case, this is a series of filters for a community built on the ABS rules, where a user can say, you know what, I need some hull structure rules, welding information, and I'm doing a fillet weld. When they do that, the relevant knowledge packet that fit the criteria will be contained in this assessment control for that particular project and that particular object you are standing in. When we create that assessment control, information from the part object or assembly object, whatever we may be on, gets sent to the assessment header. So it's kind of the metadata background of that assessment. So we can store things like the part good or part name or assembly hierarchy or whatever you want to pass back to Auros from ShipConstructor. So as the process goes on, so I have my knowledge packets, I have my assessment control, I have little bits of information I need to consider. Maybe these are work instructions, in this case they're ABS rules specific to that part if I need them. I do my work and say, all right, I applied this particular bit of information. Here's how it behaved on my particular project. Did I get my list of information there, passes and failed, I deviate. And as I'm doing that work, like I was showing information about that assessment gets stored back against that part. So things like who was doing that or created that assessment? What is the idea of the assessment? When was it last updated? What's its status? Is it red, yellow, green, whatnot? And by doing this, what we've actually done is now we've made our parts or assemblies or whatever we're working on a little bit smarter, and we're able to track status or of a project either through our Auros web interface or the same information, like I said, the status of all parts are also stored back in the ShipConstructor. So you can go into your UDA manager and say, which parts do I have are red, they're not conforming. You'll be able to find all your red items within ShipConstructor. So it's kind of the basics. It's still very much a prototype. We're working to improve it. We're going to actually run through it with some of our shipyards tomorrow and get some feedback on what we need to do to make things better. So as far as our next steps in our project, we still have a mountain of work to do. We have a lot of knowledge that's been stored in documents that has to be migrated back into knowledge packets so we can make them smarter to get them into this process. Like I said, we're going to refine the ShipConstructor connector. And once we get into a little bit more of a mature process here in the next few weeks, we're scheduled to go out to meet with our shipyards and pilot the project with them. And during those pilot implementations, we're going to collect our measurables, and then finally at the end, we'll present it back to the NSRP next spring. So that's all I have.
Thank you, Steve. Thank you,
Yeah,
Greg.
thank you.
Appreciate you making sure.